Hello seniors, today we're going to see electronic assignment 18, which is about derivatives of trigonometric functions. For this particular electronic assignment, the only new thing that you're going to be learning is the derivative of functions such as this: sine of x, cosine of x, and tangent of x. All of the other things that we have learned before, such as a derivative or using product rule, quotient rule, chain rule, and all of that apply to this same type of functions, okay? So the only new thing is that you're going to learn how to find the derivative of these functions, just as you learned, for example, the derivatives of this and this function, exponential and logarithmic. Okay, so objectives: find the derivative of x to the power of n, which is the first one we studied. These three are the new ones for today, and these two are the ones that you already know. And then solve various application problems. Okay, so we're going to read this example of how derivatives of trigonometric functions apply to real-life situations. It says, at the chocolate factory in Girardelli Square, San Francisco, California, a vat of milk chocolate is steered by a steer blade, which is driven by a wheel that pushes the blade back and forth across the bottom of the vat. So here you have a wheel which has this is the vat. Yes, at the bottom of the vat, which is attached to one part of the wheel and to the blade right here, right? So as the wheel spins, you would see that when it goes down, this blade pushes, or the rod pushes the blade towards this side, right? And when the wheel is keeping on doing the turn, the blade comes back, right? So with that mechanism, the chocolate inside of this recipient is getting mixed, right? This ensures that the chocolate gets a good mixture. Okay, so it says, in the chocolate steer, the periodic circular function of the wheel is translated into periodic linear motion of the blade. The diagram shows the mechanisms. One end of the rod is attached to a wheel, which is this part, or crankshaft, and the other end of the rod is attached to the steerer blade inside the vat, which is this part over here. As the wheel turns, the rod pushes the steerer blade backwards and forwards across the vat. The distance between the center of the wheel and the steerer blade can be modeled by the function, and we can find this by doing a graphical analysis of the situation, but we're not gonna do that right now, where d is the distance in meters and theta is the angle of rotation of the wheel in radians. To find the angle of rotation when the blade is the shortest distance from the center of the wheel, you would use the derivative of that function. Okay, so in this particular situation, you will have to apply derivative of trigonometric functions because we have cosine and sine in this case. Okay, so some properties of derivatives. This is just a review of something that we have already seen. For example, the derivative of a constant number is always 0. For example, if f of x is 3, the derivative is 0. Then if we have a constant multiple, that's if we're multiplying, for example, this case, right? If there's a number in front of the x, when we find the derivative, we just find the derivative of the x and the 3 remains as it is, right? Then sum or difference rule, which is if I have the sum or difference of two functions, the derivative of that would be just finding the derivative of each function separately. For example, this one over here, the derivative of 3x plus 2x squared is 3 plus 4x. We just find the derivative of each function independently, and then we add them both. Then we have the product rule, which is a rule that we have studied in previous classes. The quotient rule as well. We have studied this in previous classes. And the chain rule, which applies in case of composite functions, right? Which we have also studied in previous classes. Okay, so the new part is this: derivative of sine, cosine, and tangent. These are the three new formulas, which, by the way, are in the formula booklet. Let me show you. If you go to the formula booklet, here you have the three of them. This is topic 6, calculus. And if you scroll down here, you would see that we have these derivatives, and then all of the rest that we have seen already. Derivative of x to the power of n, e to the power of x, natural logarithm of x, chain rule, product rule, quotient rule. All of these rules, we have seen them all already, and these are the 3 new ones, okay? Basically, the derivative of sine of x is cosine of x. If the function is cosine of x, the derivative is negative sine of x. And if the function is tangent of x, the derivative of tangent of x is 1 over cosine squared of x. So you don't need to memorize this, people, because as you can see, these are all in the formula booklet. And we're not gonna see the demonstration of where this derivative comes from, because we're gonna waste too much time doing that. But in case you want to see where these derivatives come from, you can maybe investigate them in YouTube or however you want. But it's something that you don't need to know because you have it all in the formula booklet. Okay, so we're gonna do some examples. I've already solved this, but I'm gonna erase it to do it together. There. So it says find the derivative of each function, and the first function says f of x is equal to sine of x plus cosine of x. So to find the derivative of that function, we're going to write f prime of x is equal to the derivative of sine of x, according to our formula booklet, is cosine of x, right? So the derivative is cosine of x, and then the derivative of cosine of x, according to our formula, is negative sine of x. So this would be minus sine of x, right? The derivative of sine of x plus cosine of x. And that's it. This is the result for part A. Okay, then we have part B, which says the following. Let me write the equation. Y equals cosine of t squared. Okay, so if we want to find the derivative of this, I see that we will have to apply, in this case, a chain rule, right? Because we have the external function, which is cosine of the angle. In this case, the angle is t squared. And then we have an inner function, which is the angle itself, right? It's t squared in this case. So let me find the derivative of this function. I'm going to use the other notation just for you to remember the other notation. This is the same as saying y prime, right? The derivative of y with respect to t, because t is a variable here instead of x, would be equal to the derivative of the outer function, which is cosine of x. The derivative of cosine of x is negative sine of x. So we're going to write negative sine of t squared. Remember, the inner function remain the same, right? And then we multiply this by the derivative of the inner function. The derivative of t squared is 2t. Okay, 2t. So that's it. Now we can reorganize this in order to get our final result. So the derivative of y with respect to t is equal to a negative 2t times sine of t squared. T squared. There you go. So this is the final result for part B. Okay, then we're going to move on to exercise C, which says the following. Y is equal to 1 over tangent of x. 1 over tangent of x. Okay, so in this particular case, we could, if we want, apply the quotient rule. But I see there's an easier or shorter way to solve this derivative. Remember that we can take this up, right? If I take that up, we can rewrite this expression as tangent of x and all of this to the power of negative 1, right? If we take it to the numerator. And then this is easier to differentiate, right? If I write dy over dx, then this would be chain rule again, right? The outermost function involves the exponent here, and then the innermost function is tangent of x. So we apply the derivative for this, and we're going to have negative tangent of x. All of this is to the power of negative 2, and then we multiply this by the derivative of the inner function, which is tangent of x, And if you remember, the derivative of tangent of x is this expression over here, 1 over cosine squared of x. So times 1 over cosine squared of x. Okay, so I see that we can reorganize this. For example, if I rewrite this as, instead of having this in the numerator, I can take it down to the denominator in order to have a positive exponent. So we're going to have negative 1 on top divided by tangent of x squared, tangent of x squared times cosine of x squared. Okay? And if you remember from the trigonometry lessons we had last year, we know that tangent of x, if you remember SOHCAHTOA, right? Tangent of x is the same as saying sine of x over cosine of x. I believe that that is in the formula booklet as well. Let me see. If you go to topic 3, yes, here you have tangent of the angle is a sine of the angle over cosine of the angle. So we can say that tangent squared of x, which is what we have here, tangent squared of x is sine squared of x divided by cosine squared of x, right? So if I replace all of this here instead of tangent of x, maybe I will be able to simplify some things, okay? So that's exactly what I'm going to do. And I'm going to rewrite this as negative 1 over sine squared of x over cosine squared of x times cosine squared of x. Okay? And I see that I can simplify here cosine squared of x with cosine squared of x. So there we have the final result. The derivative of y with respect to t in this particular case is equal to negative 1 over a sine squared of x, sine squared of x. And this would be the result. Okay? So I hope this is getting clear for you guys. Now let's go to the last exercise, which is D, which says the following. F of x is equal to sine cubed of 2x. So f of x is equal to sine cubed of 2x. I think it was like that. Yes, sine cubed of 2x. Okay, so to find the derivative of this, I see that again, this is a case of chain rule, right? But this is a triple chain rule. Why? Because we have the outermost function, which involves this exponent over here, right? So it's the derivative of the exponent. Then we have a second innermost function, which is sine of the angle, and then the innermost function is the angle itself, which is 2x. Okay, so if we apply the derivative of this function and we apply a chain rule, the first part would be finding the derivative of the exponent. So this would be equal to 3 sine squared of 2x, right? Then we need to multiply this and find the derivative of sine of the angle. The derivative of sine, according to our formula booklet, is cosine of x. So we're going to write times cosine of 2x. Remember, we keep the angle the same. Whatever function we have inside, we keep it the same. And then we multiply this by the derivative of the innermost function. The derivative of 2x is equal to 2, right? And that's it. Now we can reorganize this in order to have our final result. And this would be equal to 6 times sine squared of 2x times cosine of 2x. And this is our final answer for this exercise. Okay, so I hope this is getting clear for you. Now let's see example 2, which is the last set of exercises. Again, I have already solved this, but I'm going to erase it to do it together. There you go. So it says, Find the equations of the tangent line and the normal line to the curve f of x equals cosine of 3x at the point where x equals pi over 9. Okay, so this is something that we already know how to do, right? We already know how to find the tangent line and the normal line to a curve. If you remember, there are some steps that we need to follow in order to find these equations, right? If we quickly review this, remember the first thing we need to determine is the slope of the tangent line, which is found by finding the derivative of this function and then replacing the derivative function, or replacing the x in the derivative function for the given x value in the exercise, right? Once we have the slope of the tangent line, if you remember, the slope of the normal line is the negative reciprocal of that value of the slope of the tangent line. And the last thing we need is the given point. We already have the x coordinate of the given point. So in order to find the y coordinate of the given point, we just replace this into the original function, right? And we get y. So with all of that information, the slope and the given point for both the tangent line and the normal line, we can determine the equations for both, okay? So the first thing I'm gonna do is find the y coordinate of the point, right? Of the point with x coordinate, x equals pi over 9. So to do that, I'm gonna replace this value of x into the original function. So I'm gonna find f of pi over 9. If I find f of pi over 9, this would be cosine of 3 times pi over 9. One important thing for you to remember, people, if you're going to be using your calculators, remember that whenever we have trigonometric functions, circular functions, which are these ones, cosine, sine, tangent, whatever, remember that your calculator must be set to radians, okay? Or else you're going to be getting wrong results. That's very important for you to remember. Okay, so I see that, for example, here the 3 simplifies with the 9. We have a 3 here. So this is the same as saying cosine of pi over 3. And pi over 3, if you remember how to convert this to degrees, pi over 3 is 60 degrees, right? And cosine of 60 degrees, if you remember from the left-hand rule, which we studied last year, cosine of 60 degrees corresponds or gives us a value of 1/2. So that means that the point, the known point, has coordinates. In x, it's pi over 9. And in y, it's this value over here, which is 1/2. Okay, so this is the first important piece of information that we can get from the exercise, okay? Then, the next step is to find the slope of the tangent line. To find the slope of the tangent line, I first need to find the derivative of the function. So I'm going to find f prime of x. To find the derivative of this function, I see that again, we need to apply chain rule, right? The outermost function is cosine of the angle, and the derivative of cosine is negative sine, right? So this is equal to a negative sine of 3x. We keep the angle the same, and we multiply this by the inner derivative of the function 3x, and the derivative is just 3, right? So this is the same as saying negative 3 sine of 3x. Okay. Now, in order to be able to find the value of the slope, I need to replace the value, the given value of x, which is pi over 9, into the gradient function, into the first derivative, right? So we're going to find f prime of pi over 9. F prime of pi over 9 is negative 3 sine of 3, and instead of x, we're going to write pi over 9. So same thing here. We can simplify the 3. Here we're going to have 3. So this is the same as saying negative 3 times sine of pi over 3. And if you remember from the left-hand rule, pi over 3 is 60 degrees. So sine of 60 degrees gives us, and this is a negative 3 from here, and the sine of 60 degrees is square root of 3 over 2. Okay, so this value, let me write it like this. That means that the value m tangent, the slope of the tangent, is negative 3 square root of 3 over 2. That's the slope of the tangent line for this case. So this is another important piece of information to solve this exercise. Okay, so if we have the slope of the tangent, we can also calculate the slope of the normal. Remember that the normal line is a line that is perpendicular to the tangent line. And whenever two lines are perpendicular, their slopes are the negative reciprocals of each other, right? So to find this slope of the normal, we just need to change signs of this and flip the fraction. So we're gonna get as a result 2 over 3 square root of 3. Okay, positive because this was negative for the tangent line. Okay, so there we have the other important piece of information we needed. We already have the given point, we already have slope of tangent and slope of normal. So with all of that information, we can now determine the equations. First of all, we can determine the equation of the tangent lines. I'm going to write equation of tangent line. If you remember the equation of the tangent line, the equation of any line is always given by y equals mx plus c, right? Where m is the slope and c is the y-intercept. So if I plug in my given point, which I'm going to replace in the x, y values of the equation, I am going to be able to find the value of c, right? So our given point is this one over here, so we replace the value, y is 1/2. The slope is this value over here for the case of the tangent, so negative 3 root 3 over 2 times x, which is pi over 9 in this case, plus c, okay? And then we need to solve for c. If we solve for c, we're going to get a value of 1/2. You can do this in the calculator if you want. And you're going to get this, plus root 3 over 6 pi, and this is the value of c. So once we have the value of c, we can write our final expression, writing it in this way. So this would be negative 3 root 3 over 2 x plus 1/2 plus root 3 over 6 pi. All of this would be the equation of the tangent line, okay? And if you want to write this in decimal, maybe if you did this in a calculator, the answer would be 2.60x plus 1.41. If you do this in the calculator, both of these results are equally valid, okay? Okay, so that's the equation of the tangent line. So we're going to do exactly the same thing. I'm going to separate this a little bit. We're going to do exactly the same thing in order to determine the equation of the normal line. So equation of normal line. To find the equation of the normal line, it's the same thing, right? Y equals mx plus c. But now we need to use this value for the slope. The point is the same one, right? This one over here. So we're going to replace values. 1/2 is equal to, slope is 2 over 3 root 3, x is pi over 9 plus c. So then we solve for c and we get a value of 1/2 minus 2 pi over 27 root 3. This is the value of c. So once I have the value of c, I can write the equation. So it's y equals 2 over 3 root 3x plus 1/2 minus 27 pi over 27, plus 2 pi, this one. 2 pi over 27 root 3. all of this would be the equation of the normal line. Okay, if you use calculator, the equivalent result for this is the following: y equals 0.38x plus 0.37. This is the equation of the normal line for this particular situation. Okay, so I think that's it. Yes, that's it. You see that all of the process, all of the concepts are exactly the same that we have studied in previous classes, right? The only new thing that we have learned today are this new three derivatives, right? The derivative of the trigonometric functions, sine, cosine, and tangent. But all of the rest, all of the concepts, all of the principles apply in the same way, right? So yes, that's it. I hope this was clear for you people. If not, please let me know. We're going to clear doubts in future live sessions. See you.